Hello there. So this is the continuation of the Perceptron algorithm introduction, and in this video I am going to demonstrate to you a simple implementation of the Perceptron algorithm written in Python. So as a disclosure, I am not that expert or advanced yet in Python, so yeah, just don't mind about the code too much. But I'm open for criticism because that is how we improve, right? But yeah. So what I did is I hopped into this, or I encountered this website which is openml.org, and they have a bunch of datasets, like a bunch of datasets, and I chose this one. And so this dataset is a collection of, we have information here. So this is just a classification of whether a credit data. So yeah, we can see it here. This dataset classifies people described by a set of attributes as good or bad credit risks. So yeah, it just classifies people whether they have a good or bad credit risk, and that's all. So we have here, so it says that the data set comes with a cost matrix. So it just means that it is worse to class a customer as good when they are bad than it is to class a customer as bad when they are good. So that means it hurts a lot more when they say someone who has actually a bad credit risk and then classify that as a good credit risk. It would hurt more if we do that compared to when we wrongly classify someone who has actually a good credit risk, but then we wrongly classified that person to have a bad credit risk. But I haven't used this yet, perhaps in the next videos, but yeah. So we also have here attribute description. It will just provide us some descriptions about these features here. So we have 21 features. This one is the classification. It is the target. So this one is the label, either good or bad. And so we're not gonna be discussing everything here because there's just a lot of them. So what I did is I just downloaded that CSV. So we have that here now, and then I split this into two. So the first one is the the training data. So these are the data set we're going to use for the training, or to train the model to get the weights and the bias. And this one is just to see how our model performs based on the parameters we've got from the training function. So here's our main program. We just pulled the dataset, and then in here we converted these features to vectors. So there's a rule, or to convert features to vectors. So numerical features like this one, duration, is just copied and pasted, or copy pasted. Boolean Boolean features like answers yes or no is converted to, if yes, converted to 1, if no, converted to 0. And the categorical features like this one, new car, so different categories. So what we are going to do is convert each category into a boolean. So like for this one is new car, either 1 or 0, and then this one is used car, 1 or 0. So we convert them all to boolean, and so we get a set of features that can be represented by a vector, or can represent a vector, I mean. I believe I have a other video for that to explain how to convert a feature to feature vectors, so you can just check that out. So what I did here is I fed the training data to this function that I just created and applied the modifier for each example just to convert the example from feature to feature vectors. And this modifier here is looking nasty but yeah, doesn't really, no one really cares, I don't think so yeah. So as you can see here, I just converted the categorical features to each categorical feature, I mean each category for the categorical features into binary features. And yeah, so and in here we have our training function. So bias initialized to 0, weights, so we got the features. I just got the features from the keys of the examples, and then for each feature I just initialized the weight for a specific feature to 0, just like what we had in the previous video where I showed the pseudocode of the algorithm. And then this one, this is the iteration based on the max iterations set as an argument. And then for each example in our data, we compute the activation, and then we compare that to the actual activation or the label of the data. So if we got the wrong activation, update the weights, and then also update the bias, and then do that for all the examples, and then do that again. I mean do that over and over depending on the iterations provided as an argument, and then we get the weights, the bias, and I also just got the features here because I'm going to need that in testing. So let's just take a look at how the weights look like. So I've been testing this before and I'm not sure if I'm getting a really accurate model, but yeah, let's just, oh no, not npm. So let's just, what? Oh, I did not print it. So print. I know it says pp there, but just don't mind that, and I hope this video is not gonna be taken down because of that. Okay, so we can see here that, so the age, this is the, what you call this, the weight of the age, weight of the credit amount, so it influences to the negative activation duration, so on so forth. So that's how the weights look like. And then what I did here is, since we already got the parameters, we got the weights, we got the bias, so what I did next is I wanted to know or to see how my model works based on the parameters I got. And so I just used the test data, the second split of the data I've got. And for each example, I just computed for the prediction or the predicted activation, and then compared that to the actual label, and then I just computed the accuracy. So if you're going to do this, I haven't saved it. So again, so as you can see, I got 83%. So the accuracy of the model based on the test data, using the parameters I got when I trained the model, the accuracy is 83%. Decent enough? I'm not sure. I perhaps 90% is decent, but I think 83. When you get 80%, when you are correct 80% of the time, I do think that's huge, because when you're playing games in Dota, like 60% win rate is actually good, because you win more than you lose. When you get a win percentage of 80%, that's big. That's big. So yeah, but I'm getting sidetracked again. But basically, that's the demonstration of a very, 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 very simple implementation of the perceptron algorithm written in Python. And I hope you have learned something. And as always, have a great day and see you next time.